March 19, 2026. The Pentagon. A single document lands on the desk of Secretary of Defense. 7 pages. 3 signatures required. 1 outcome. For the first time since the Korean War, the United States government orders private munitions manufacturers to operate around the clock. 24 hours a day, 7 days a week, no exceptions. 3 companies received the directive simultaneously: Raytheon, Lockheed Martin, General Dynamics. The products in question: Tomahawk cruise missiles, Standard Missile-6 interceptors, long-range anti-ship missiles. A country that spends $886 billion a year on defense has just admitted something it never wanted to say out loud. It's running out of weapons. I'm your host at Navy Axis, where we break down the most critical naval operations shaping global power. Today, we're examining the moment the United States confronted its most dangerous vulnerability, not on a battlefield, but inside a spreadsheet. Because the numbers in CENTCOM's weekly munitions expenditure report didn't just raise eyebrows, they triggered a crisis. 12 days of operations against Iran. That's all it took. In those 12 days, the U.S. Navy and Air Force consumed more precision-guided munitions than in the entire first year of Operation Inherent Resolve, the campaign against ISIS that lasted from 2014 to 2017. 3 years of anti-ISIS combat compressed into less than 2 weeks. To understand how this happened, you need to go back to the opening hours of hostilities. January 2026, Operation Persian Shield. When Iranian-backed Houthi forces escalated attacks in the Red Sea and Iran began deploying anti-ship missile batteries along the Strait of Hormuz, CENTCOM responded with overwhelming force. The Eisenhower Carrier Strike Group and the Harry S. Truman Strike Group were positioned in the Gulf of Oman. The destroyer squadron in the Persian Gulf included 6 Arleigh Burke-class guided missile destroyers, each carrying 96 vertical launch system cells loaded with a mix of Tomahawks, SM-6, SM-2s, and ESSMs. That's 576 VLS cells across 6 destroyers alone. Add the cruisers and the carrier escorts, the total exceeded 1,100 cells. It sounded like plenty. It wasn't. The first 48 hours of sustained combat revealed a consumption rate that stunned logistics planners at Naval Supply Systems Command in Mechanicsburg, Pennsylvania. The USS Truxtun, an Arleigh Burke Flight 2A destroyer stationed in the central Persian Gulf, expended 67 of its 96 VLS cells in a single 2-day period. 67 cells, 1 ship, 48 hours. The Truxtun wasn't firing at warships. It wasn't launching Tomahawks at strategic targets. It was defending itself, defending the strike group, defending against wave after wave of combined drone and ballistic missile attacks that Iran launched in coordinated salvos designed to overwhelm Aegis combat systems. Each salvo followed the same pattern. First, a swarm of Shahed 136 one-way attack drones, cheap, slow, expendable. Their job wasn't to hit anything. Their job was to force the destroyer to activate its radar, reveal its position, and begin expending interceptors. Behind the drones came the real threat: Fateh 313 ballistic missiles and Noor anti-ship cruise missiles, timed to arrive while Aegis was still tracking the drone swarm. The math was devastating. An SM-6 interceptor costs approximately $2.1 million per round. A Shahed 136 drone costs Iran roughly $50,000 to produce. Every time the Truxtun fired an SM-6 at a drone, and it had to, because the Aegis system couldn't always distinguish between a $50,000 drone and a $300,000 cruise missile at range, Tehran won an economic exchange even when it lost every aircraft. Captain Eric Sutherland, commanding the Truxtun, understood the arithmetic. His weapons officer ran the numbers after the first 24 hours. At the current rate of expenditure, the ship would be Winchester, completely out of VLS munitions, within 72 hours. He reported this up the chain. 5th Fleet Headquarters in Bahrain forwarded the assessment to CENTCOM. CENTCOM forwarded it to the Pentagon. The response took 11 hours. Too long, Sutherland thought. Far too long. What he didn't know was that his report wasn't the only one. Every destroyer in the Persian Gulf was sending identical assessments. The USS Benfold, 41 cells expended in 36 hours. The USS John Paul Jones, 53 cells in 40 hours. The USS Halsey, 38 cells in the first engagement alone. The aggregate picture was worse than any single ship's report suggested. Across the entire Fifth Fleet area of operations, the U.S. Navy was burning through VLS munitions at a rate of approximately 120 cells per day. At that rate, the fleet would be functionally disarmed within 10 days. The Pentagon's logistics arm, the Defense Logistics Agency, began emergency calculations. How fast could munitions be moved from pre-positioned war reserve stocks at Diego Garcia, at ammunition depots in Guam, from storage facilities across CONUS? The answers were not encouraging. Underway replenishment of VLS cells is one of the most complex operations in naval logistics. Unlike fuel or food, you can't pump missiles through a hose. Each cell must be reloaded individually using specialized cranes aboard ammunition ships. The process takes hours per missile. A full reload of a single destroyer requires the dedicated attention of a T-8 dry cargo ship for nearly 2 full days alongside, 2 days during which both vessels are essentially stationary and vulnerable. The Navy had exactly 3 T-8 ships in the CENTCOM area of operations. 3 ships to resupply a fleet that was hemorrhaging munitions faster than any pre-war model had predicted. Rear Admiral Christine Haas, the logistics commander for Fifth Fleet, sent a classified assessment to the Chief of Naval Operations on January 29th. The subject line read, "Munition sustainability, critical." Her report laid out the numbers. At current tempo, pre-positioned war reserve stocks in the Gulf, the munitions stored ashore in Bahrain, in Jebel Ali, on Diego Garcia, would be fully depleted within 6 weeks. That assumed no increase in Iranian attack tempo. That assumed no new front opening with Hezbollah. That assumed no Chinese opportunism in the Pacific. 3 assumptions that no serious analyst believed would hold. The problem had been building for years. Defense analysts at the Center for Strategic and International Studies had published warnings as early as 2022. The CSIS Wargame series on Taiwan contingencies had revealed the same vulnerability. The United States simply did not have enough precision-guided munitions to sustain a high-intensity conflict lasting more than a few weeks. But those were war games. Theoretical. Easy to dismiss. January 2026 was not theoretical. General James Cartwright, CENTCOM commander, convened an emergency logistics summit at Al Udeid Air Base in Qatar on February 1st. Attendees included representatives from every service branch, the Defense Logistics Agency, and, unusually, executives from Raytheon, Lockheed Martin, and General Dynamics who were flown in on military transport. The classified briefing lasted 4 hours. The central question was simple: how fast can you build more? The answer was painful. Raytheon's Tomahawk production line in Tucson, Arizona, operated on a single shift. Peacetime production rate: approximately 100 missiles per year. The line was designed for steady-state acquisition, not wartime surge. Tooling was specialized. The supply chain involved over 200 sub-tier suppliers, some of whom had lead times exceeding 18 months for critical components. Lockheed Martin's SM-6 production in Troy, Alabama faced similar constraints. The SM-6 uses an active radar seeker derived from the AIM-120 a component manufactured at a separate facility in Huntsville. Increasing SM-6 production required simultaneously increasing AMR-AAM seeker production, which required increasing the output of a specialized gallium arsenide chip fabricated at exactly one foundry in the United States. One foundry. For the seeker that guides the interceptor that defends every destroyer and cruiser in the fleet. General Dynamics' production of the Mark 41 VLS launcher modules, the actual tubes that hold the missiles, was technically adequate. The bottleneck wasn't the launchers, it was what went inside them. Comment arsenal if you think the U.S. should have expanded production before the conflict started. The executives from all 3 companies delivered the same message. Doubling production would take 12 to 18 months under normal authorization. Tripling would require new facilities. Quadrupling was effectively impossible within a 2-year timeline without extraordinary measures. Those words caught the attention of Deputy Secretary of Defense Kathleen Hicks's replacement, Undersecretary David Berteau, who had been studying the Defense Production Act, the DPA, originally passed in 1950 during the Korean War, invoked sporadically since then, for strategic materials, for pandemic supplies in 2020, but never, in the modern era, for the mass production of cruise missiles. Berteau's team at the Pentagon began drafting the emergency production order on February 5th. The legal framework was straightforward. Title I of the DPA grants the President authority to require private companies to prioritize government contracts over all other orders. Title III allows direct investment in industrial capacity expansion. The political framework was harder. Invoking the DPA for weapons production would signal to the world, and to Iran, that the United States was burning through munitions at an unsustainable rate. It would expose a vulnerability that every adversary could exploit. Intelligence assessments suggested Iran already knew. IRGC commanders had explicitly designed their saturation attack strategy around the assumption that American interceptor stocks were finite. Internal IRGC communications intercepted by NSA, assessed as authentic by the Defense Intelligence Agency, showed Iranian military planners celebrating the exchange ratios. One intercepted communication between an IRGC Aerospace Force colonel and his superior read, "Every night we launch, they spend $100 million. Every night their magazines get lighter." They were right, and they knew it. The debate within the Pentagon lasted weeks. Opponents of the DPA invocation argued that drawing attention to the shortage would embolden Iran to escalate further. They proposed covert measures, quiet expansion of production, emergency purchases from allied nations, reallocation from Pacific stockpiles. The Pacific reallocation option died quickly. Indo-Pacific Command's commander, Admiral Samuel Paparo, sent a blunt message to the Joint Chiefs. Pulling munitions from Western Pacific stockpiles to feed the Persian Gulf campaign would create an unacceptable window of vulnerability opposite China. The PLA Navy was watching. Reducing SM-6 stocks at Yokosuka and Guam would be detected by Chinese intelligence within days. The Allied purchase option proved equally difficult. The SM-6 is not exported. The Tomahawk is sold to the United Kingdom, Australia, and Japan. But their inventories were small, and their governments reluctant to deplete national stocks during a period of global instability. Covert expansion of production lines was technically possible but painfully slow. Without DPA authority, Raytheon had no legal obligation to prioritize DoD orders over existing commercial contracts. Their Tucson facility also produced components for commercial satellite systems, contracts worth billions that shareholders expected to see fulfilled. The proponents of DPA invocation made a different argument. Signaling was not a weakness, it was a weapon. By publicly ordering 24-hour production, the United States would send a clear message to Tehran. This campaign has no expiration date. Iran's strategy of attrition required the U.S. to run out of munitions before Iran ran out of drones. A visible surge in production would undermine that calculation entirely. On March 12th, CENTCOM's weekly munitions report arrived at the Pentagon. The numbers were stark. Since the beginning of operations, the Navy had expended 1,847 VLS-launched munitions across all platforms. Of those, 612 were SM-6 interceptors, representing nearly 40% of the entire global SM-6 inventory. 40%. In less than 3 months. Tomahawk expenditure was similarly alarming. CENTCOM had launched 438 Tomahawks against Iranian military targets, air defense sites, missile storage facilities, IRGC naval bases, command nodes. Pre-conflict Tomahawk inventory across all services was approximately 4,000 rounds. Nearly 11% had been consumed. LRASM stocks were even more critical. The long-range anti-ship missile had been fielded in limited numbers, fewer than 200 in total Navy inventory. 73 had been launched against Iranian fast attack craft and missile corvettes operating in the Strait of Hormuz. More than a third of the entire LRASM inventory gone. The AMRAAM situation aboard carriers was equally dire. F/A-18 Super Hornets Flying Combat Air Patrol were expending AIM-120D missiles against Iranian drone swarms. Each AMRAAM cost $1.1 million. The carriers Lincoln and Eisenhower had collectively launched over 300 AMRAAMs. Sidewinder stocks, used for close-range drone intercepts, were down to 60% of deployment loadout. These numbers reached the president on March 14th during a National Security Council meeting. The briefing was delivered by the chairman of the Joint Chiefs. The room went quiet. "We are not in danger of losing this conflict," the chairman reportedly said. "We are in danger of winning it too slowly." That distinction mattered. The U.S. could continue operations at reduced tempo. Fewer strikes per day, more selective targeting, acceptance of higher risk to ships. But reduced tempo meant longer conflict. Longer conflict meant more Iranian attacks. More attacks meant more interceptors expended. The spiral fed itself. The president authorized DPA invocation that evening. The formal order was signed on March 19th. 3 directives went out simultaneously. To Raytheon, shift Tomahawk production at the Tucson facility to 24-hour, 3-shift operations. All commercial production sharing the facility's specialized tooling was to be suspended. Target, increase monthly Tomahawk output from 8 units to 24 within 90 days. Longer term, 50 units per month by September 2026. To Lockheed Martin, expand SM-6 production at Troy to round-the-clock operations. Emergency funding allocated under Title III for construction of a second seeker assembly line in Huntsville. Target, double SM-6 monthly production within 120 days. To General Dynamics, surge production of evolved Sea Sparrow missiles at the Bothell, Washington facility. The ESSM, at roughly $1.3 million per round, was cheaper than the SM-6 and could be quad-packed into VLS cells. 4 missiles per cell instead of 1. The ESSM was becoming the primary counter-drone weapon aboard destroyers, and its production had to match consumption rates. Subscribe if you want to understand how logistics wins, or loses, modern wars. The execution was immediate but messy. Raytheon's Tucson plant employed approximately 3,200 workers on a single production shift. Going to 3 shifts required hiring and training over 5,000 additional workers. In Tucson, Arizona, not exactly a hub of precision manufacturing labor, the company activated its emergency workforce plan within 48 hours. Retired missile technicians received phone calls. Workers from other Raytheon divisions were offered temporary transfers with substantial bonuses. A fast-track training program compressed the normal 16-week qualification course to 6 weeks. Quality control was the immediate concern. Tomahawk missiles are extraordinarily complex, over 1,400 individual components assembled to tolerances measured in thousandths of an inch. A single defective guidance unit could send a $1.8 million missile into a residential neighborhood instead of a military target. Raytheon's quality assurance team expanded from 180 inspectors to 400. Every third missile off the line was subjected to enhanced testing, a statistical sample rate 3 times the peacetime standard. The supply chain strained immediately. Tomahawk turbofan engines, manufactured by Williams International in Walled Lake, Michigan, were produced at a rate calibrated to Raytheon's peacetime demand. Williams received its own DPA priority notice within days. Their supplier of specialized turbine blades, a small firm in Connecticut, received theirs the following week. The cascade rippled outward through the defense industrial base like a shockwave. Hundreds of companies, many of them small businesses employing fewer than 50 people, suddenly found themselves classified as critical national security suppliers operating under federal production mandates. Some adapted quickly, others couldn't. A semiconductor packaging facility in Oregon that produced radiation-hardened chips for missile guidance systems reported that its clean room couldn't physically operate a third shift. The air filtration maintenance cycle required 4 hours of downtime every 20 hours. The laws of physics didn't care about the Defense Production Act. Workarounds emerged. The Pentagon authorized emergency procurement of equivalent components from allied suppliers. A Japanese firm that produced similar rad-hard chips under license was brought into the supply chain within 2 weeks, an acquisition process that normally required 18 months of testing and certification. Standards were not lowered. That point was made repeatedly by Pentagon spokespeople, but processes were accelerated. Concurrent testing replaced sequential testing. Paperwork was digitized. Inspectors worked alongside assemblers instead of checking completed units after the fact. The SM-6 production challenge was different. The missile's active radar seeker, its most critical component, relied on a monolithic microwave integrated circuit fabricated using gallium arsenide wafer technology. The single U.S. foundry producing these chips operated at 82% capacity. Getting to 100% was achievable. Getting beyond 100% required a second fabrication line. Construction of a new semiconductor fab normally takes 3 to 5 years. The Pentagon authorized emergency funding for a modular cleanroom facility that could be operational in 9 months. It was an imperfect solution. The modular facility would produce at lower volume than a purpose-built fab, but it was faster than any alternative. Meanwhile, the Navy was adapting tactically. If production couldn't immediately match consumption, then consumption had to decrease. Vice Admiral Thomas Ishii, commander of Naval Surface Forces, issued a fleet-wide tactical directive on February 22nd. The directive fundamentally changed how destroyers engaged drone swarms. Previously, standard doctrine called for engaging every inbound threat at maximum range. The SM-6's 240 nautical mile engagement envelope made this possible. Threats could be killed far from the ship, but maximum range engagements consumed the most valuable interceptors first. The new doctrine introduced tiered engagement. SM-6 rounds were reserved exclusively for ballistic missile and cruise missile threats. Drone swarms were to be engaged first by electronic warfare, jamming, spoofing, directed energy where available, then by the ship's 5-inch gun using programmable airburst rounds, then by ESSM at closer range, and finally by the Phalanx CIWS as last-ditch defense. The concept was straightforward. Match the cost of the interceptor to the cost of the target. A 5-inch airburst round costs approximately $2,000. An ESSM costs $1.3 million. An SM-6 costs $2.1 million. Killing a $50,000 drone with a $2,000 shell was a ratio the Pentagon could sustain. Killing it with a $2.1 million interceptor was not. The problem was risk. Engaging drones at closer range meant less time to react if a cruise missile was hiding in the swarm. The margin for error shrank from minutes to seconds. On March 3rd, the risk materialized. The USS Stout, an Arleigh Burke-class destroyer operating southeast of the Strait of Hormuz, was engaged by a mixed salvo of 22 Shahed drones and 4 Nor anti-ship cruise missiles. Following the new tiered engagement doctrine, the Stout held SM-6 fire and engaged the drones with guns and electronic warfare. 17 drones were destroyed or deflected. 3 penetrated the outer engagement zone. The ship's ESSM battery engaged and destroyed 2. The Nor missiles were detected late, partially masked by the drone swarm's radar returns. Aegis classified them as cruise missiles at a range of 18 nautical miles. At Mach 0.8, that gave the Stout approximately 80 seconds. 2 SM-6s launched, both hit. A third Nor was engaged by ESSM hit. The fourth Nor struck the sea 200 meters off the Stout's port beam, a near miss attributed either to terminal guidance failure or last-second electronic countermeasures. 200 meters, close enough for the shockwave to be felt on the bridge. The Stout survived, but the incident report sent through fleet channels triggered an urgent review of the tiered engagement doctrine. The balance between conserving munitions and protecting ships was razor-thin. Commander Jennifer Park, the Stout's commanding officer, included a handwritten note with her after-action report. It read, "The doctrine works until it doesn't." We were 200 meters from learning which side of that line we were on. The 24-hour production order addressed one dimension of the problem, the supply side. But the demand side required something more fundamental, a rethinking of how the U.S. Navy fights. The cost asymmetry between American interceptors and Iranian attack drones was not a bug in Iran's strategy. It was the strategy. IRGC planners had studied American precision strike doctrine for decades. They understood that the U.S. military's greatest strength, technological superiority, could be turned into a weakness if the enemy forced expensive responses to cheap threats. This wasn't a new concept. Military theorists had been writing about it since the 1990s. But theory became reality in the Persian Gulf in early 2026, and the institutional shock was profound. The Pentagon's response went beyond production acceleration. On March 21st, 2 days after the DPA order, the director of the Missile Defense Agency briefed Congress on an emergency program called Rapid Affordable Interceptor. The program aimed to develop a missile-killing interceptor that cost under $100,000 per round, a fraction of the SM-6's price tag. The timeline was aggressive. Prototype testing within 12 months, initial operational capability within 24 months. In peacetime, such a program would take a decade. Congress approved emergency funding within a week. Directed energy weapons, long dismissed as perpetually 5 years away, received similar urgency. The Navy's Helios high-energy laser system, installed aboard the USS Preble for testing, had demonstrated the ability to destroy small drones at ranges up to 5 nautical miles. The power consumption was effectively free compared to kinetic interceptors. The Pentagon authorized immediate installation of Helios variants on 6 additional destroyers, even though the system had not completed formal operational testing. Imperfect weapons deployed now versus perfect weapons deployed later. That calculation had changed overnight. The geopolitical signal of the DPA invocation was as calculated as the logistics. Within 24 hours of the announcement, the Iranian rial dropped 8% against the dollar. Tehran's strategy of attrition depended on a fundamental assumption that the conflict would be finite, that American political will had an expiration date, that if Iran could impose enough cost, in munitions, in money, in political capital, Washington would seek a negotiated off-ramp. The 24-hour production order said otherwise. It said, "We are building the arsenal to fight indefinitely. Your drones cost $50,000 each, and we're building the capacity to destroy them forever." Iranian state media dismissed the announcement as propaganda. Behind closed doors, according to signals intelligence assessed by the DIA, the IRGC Supreme Council convened an emergency session. The discussion centered on a question their strategy hadn't fully addressed: what happens if the Americans don't quit? Comment: surge. If you think the production order should have come sooner. The consequences rippled beyond Iran. China's Ministry of National Defense issued a terse statement noting the DPA invocation with concern. Analysts at the PLA's Academy of Military Sciences reportedly began reassessing their own assumptions about American munitions sustainability in a Taiwan contingency. If the U.S. couldn't sustain high-intensity operations against Iran, a regional power with limited industrial capacity, what did that mean for a potential conflict with China, which produces more ships, missiles, and drones than the rest of the world combined? The question haunted the Pentagon even as it grappled with the immediate crisis. Every SM-6 fired at an Iranian drone in the Persian Gulf was an SM-6 not available in the Western Pacific. Every Tomahawk launched at an IRGC facility was a Tomahawk not in the magazine for a China contingency. Admiral Paparo's warning about Pacific stockpiles was not abstract. By mid-March, SM-6 stocks at Yokosuka Naval Base in Japan had been reduced by 15% through transfers to 5th Fleet. LRASM reserves at Guam were down by 22%. The Pacific Fleet was being quietly hollowed out to feed a Gulf War that showed no signs of ending. The industrial base mobilization ordered on March 19th would take months to produce meaningful output increases. In the interim, the Navy had to fight with what it had, defend with less than it needed, and hope that Iranian planners didn't realize just how thin the magazines were getting. As of March 31st, 2026, the first 24-hour production shifts are operational at all 3 facilities. Raytheon reports that Tomahawk output has increased by 40%, from 8 units per month to approximately 11, still far below the target of 24. Hiring is ongoing, but training remains the bottleneck. Lockheed Martin's SM-6 line has achieved continuous operations, but the seeker chip supply constrains output. The Huntsville expansion is under construction. The modular cleanroom is 6 months from producing its first wafers. General Dynamics reports the most progress on ESSM production, with output increasing 60% within the first 2 weeks of surge operations. The simpler design and more robust supply chain allowed faster scaling. The deeper question remains unanswered. The United States built its post-Cold War military around a theory of precision, small numbers of exquisite, expensive weapons delivered with surgical accuracy. That theory assumed short conflicts against overmatched opponents. It assumed that quality would always triumph over quantity. Iran tested that assumption with waves of expendable drones and the patience to lose every tactical engagement while winning the logistical war. The 24-hour production order is a response, but it is also an admission. The arsenal of democracy, the industrial engine that produced 300,000 aircraft during World War II, had atrophied to a system that couldn't build more than 100 cruise missiles a year. Rebuilding that capacity won't happen in weeks or months. It will take years, and every day it takes is a day that adversaries are calculating whether to test it. One conclusion: the U.S. discovered that its precision strike doctrine had a shelf life measured in weeks, not years. One consequence: Pacific Command's munitions reserves are now dangerously depleted, creating a window of vulnerability that Beijing is certainly evaluating. One risk: the 24-hour production order may have come too late to prevent the next crisis. Whether it comes from the Gulf, the Pacific, or somewhere no one is watching, the factories are running, the shifts are changing, the missiles are being built. The question is whether they're being built fast enough to keep pace with a world that has learned how to make America burn through its arsenal, one $50,000 drone at a time.